Hello, classmates. Hi, ma'am. Uh, Today I'm gonna be discussing about the infiltration and percolation processes and measurements. So, infiltration and percolation. So, what is infiltration? Infiltration is the process by which precipitation or water soaks into subsurface soils and moves into rocks through cracks and pore spaces. So, as mentioned before, the bulk of rainwater and melted snow end up filtrated, but where does it go in the ground? Water may get absorbed by the soil and may stay in the soil for a long time until it gradually gets evaporated. If there is a lot of vegetative covers, the infiltrated water can also get absorbed by plant roots and later transpire. Infiltration occurs in the upper layers of the ground but may also continue further downwards into the water table. So here are the following methods of determining infiltration. So infiltrometers, observation in pits and ponds, placing a catch basin below a laboratory sample, artificial rain simulators, hydrograph analysis. So what are infiltrators and infiltrometers? So it is a double ring infiltrometer is another way of determining the field saturated hydraulic conductivity of the surface soil. So it consists of open-ended inner and outer rings that are driven concentrically into the soil at a given depth. As water infiltrates into the soil from the inner ring, an equal amount of water flows into the inner ring from the Marriott bottom to keep the head constant. So another method is observing from infiltration pits and ponds. By noting the depression in the level of water in the pits and ponds and deducting the loss due to evaporation, an idea about the infiltration rates in such soils can be obtained. So infiltration basins or ponds are vegetated depression designed to store runoff on the surface and infiltrate it gradually into the ground. So some advantages are that they are dry except in periods of heavy rainfall, reduces the volume of runoff from a drainage area, can be very effective at pollutant removal via filtering through the soils, but one of the disadvantages are that it can be potential in high failure rates due to improper siting, poor design and lack of maintenance, and inappropriate pre-treatment is not incorporated and comprehensive geotechnical investigations required to confirm suitability for infiltration. So another is by placing a catch basin called a lysimeter, an apparatus for measuring change due to moisture loss, percolation, etc., undergone by a body of soil under controlled conditions. Under a laboratory sample or at some depth below the land surface, the infiltrating water can be measured and the infiltration rate in the soil can be obtained. So here we have a picture of a lysimeter. So artificial rain simulator. It's an artificial rainfall simulator for model tests of landslide designed to include water reservoirs, water pressure control, and rainfall drop making needles. To maintain the rainfall intensity, the water level of reservoir is kept constant by a servo control system. Water is applied by artificial showers at a uniform rate. The resulting surface runoff is measured and the infiltration capacity of the soil is determined. So in the PDF given by ma'am, uh, their rain simulators is a small piece of land in which they use that land to simulate rainfall. But in modern times, we now have mobile rain simulators, as you can see from the picture. So these are artificial rain simulators, which can be brought and used in determining infiltration. So another method is hydrograph analysis. By knowing accurately the varying intensities of rainfall during a storm and the continuous record of the resulting runoff, the infiltration capacity can be determined. So here, a hydrograph is a graphical plot of discharge of a natural stream or river versus time. It shows variations of discharge with time at a particular point of a stream. It also shows the time distribution of total runoff at the point of measurement. Discharge is plotted on y-axis and the corresponding time is plotted on x-axis. So the flood analysis and derivation of unit hydrograph, a single peak hydrograph is required. So hydrograph analysis is the most widely used method of analyzing surface runoff. Infiltration rate. So we will be using Horton's equation in determining an example later on. So what are infiltration indices? It is the maximum rate at which water can enter through the soil surface at a particular point of time under the given set of conditions. By now, it is clear that actual rate of infiltration will be less than infiltration capacity unless the net rainfall rate that reaches the ground after fulfilling retention is equal or more than infiltration capacity. So it's saying if there is in a case in which the rainfall will overflow and the container cannot hold it anymore. And so the infiltration capacity goes on reducing as the soil profile becomes saturated. Like infiltration, the infiltration capacity also depends on soil type, moisture content, organic matter present in the soil, vegetal cover, and season. So index. The index is the portion of average rate of rainfall during any storm which gets lost by the processes of interception, depression storage, and infiltration taken together. It can therefore be defined as that rate of average rainfall during any storm beyond which the volume of remaining rainfall equals the volume of direct surface runoff. So W index is the index which gives the average rate of infiltration in that time period of the storm rainfall during which rainfall intensity is greater than W. Thus, it can be said to be refinement over index, which apart from infiltration also includes interception and depression storage. So here we have a problem. So a drainage basin has a catchment area of 0.5 kilometer square. A 5-hour storm has occurred on the basin with the following rainfall intensities. So in the line of the x-axis, it shows the average rate of infiltration and surface retention. Together with the index, we have to find the value of the index. So from the given hydrograph, total rainfall is in 5-hour storm is 60 millimeters. So the total volume of direct surface runoff is 0.232 times 60 times 60 and times 24. It will be equal to 20,045 meter cube. So from the definition of the index, it is a portion of the average rate of rainfall above which volume of remaining rainfalls equal volume of runoff. So the volume of water loss equals to the total rainfall volume minus the total runoff volume and infiltration plus retention. So the overall calculation will lead us to 3.98 millimeters. So percolation. Water infiltrates the soil by moving through the surface. Percolation is the movement of water through the soil itself. Finally, as the water percolates into the deepest layer of the soil, it reaches groundwater, which is water below the surface. The upper surface of this underground water is called the water table. As groundwater can intersect with surface streams, it can appear as the surface as springs and it flows generally downhill toward the ocean. So that here are the steps in determining percolation rate. So you need to dig a hole 4 to 8 inch using a shovel, and it needs to at least have 3 hole spaces where the drain field is planned. Next is roughen the sidewalls and bottoms. So you need to smooth out the hole when you are digging so that it will not collapse inside. So next is pre-soak the soil. So you need to fill the hole with clear water to at least 12 inches above the gravel. So you continue to add water until the soil becomes saturated. The fourth step is measuring the soil percolation rate. By measuring the percolation rate the day after the saturation process, except in sandy soils, as said, you will need to record the readings on paper and store in the with the on-site system records. So next is calculating the percolation rate. The percolation rate is the average time in minutes required for water to fall 1 inch. So you will record the percolation test data from each hole, divide the number of minutes elapsed by the drop in inches using the last 30 or 10-minute reading taken from each hole. Next is calculating the field percolation rate. So determine the percolation rate for the entire field by averaging all the test holes, and if the percolation test results for all the holes is more than 20 mpi, there is a considerable variation in the soil type. So determines site suitability. So if the percolation rate for the site is faster than 5 mpi, the soil is unsuitable for a drain field system. Wastewater would travel too quickly through the soil to be treated properly. So next is the last step is keep the soil percolation test data. If a construction permit is required, the percolation test results must be submitted along with the required data and following test results. So what is the difference between infiltration and percolation? So infiltration, as discussed previously, is the water absorbed by the soil of any area during a rainfall. It is also a process in which to measure the speed of water in which it enters the soil in case of rain or when water is supplied to the ground through human-made means. The speed of infiltration is measured in the amount of water absorbed per hour, but it can be uh, in any time, in minutes or in days. So this amount is in inches or in millimeters. The infiltration capacity of a soil is high at the beginning of a storm and has an exponential decay as the time elapses. So if as said, if there is a storm, of course the storm will vanish, but the problem you are trying to identify is how long the storm will pass or how long it will end. So you will determine need to solve it by determining the infiltration. So percolation, it is the descending motion of infiltrated water through soil and rock layers. Infiltration, it is also infiltration occurs closer to the surface of the soil. Infiltration delivers water from the surface into the soil and plant rooting zone, while percolation moves it through the soil profile to replenish groundwater supplies or become part of subsurface runoff process. So the percolation process represents the flow of water from unsaturated zone to the saturated zone. So that is all. Thank you for listening. Hope to see you soon.